Hi and good morning to everyone, and Dr. Fawzatu Shimal. Today, I want to present roughly about the title of my work, which is the preparation of polyethylene MOHD modified with trimethylsulfonium for packaging application. Let me introduce myself first. I am Puteri Nur Ainin Sofiya binti PUTRA YAMANI, second year students from Bachelor of Science, Chemical Sciences with Honour from University Malaysia Terengganu. This work is about the research to modify the properties of food packaging application in our daily life. We are focusing on one of the modification of the montmorillonite clay with the presence of surfactant. The cationic surfactant, which is trimethylsulfonium iodide, has been used in the modification of montmorillonite surface. The improvement of food packaging can help in reducing the spoilage of food in daily life and avoid the statistic of food spill. Along this research, we can identify how the surfactant can improve the properties of montmorillonite clay to increase the dispersion rate inside the polymer matrix. The main problem leading to this research is because the sale of food become a worldwide issue. The statistics shows that more than 345 million people around the world facing food crisis in 2023, which is the double number from 2020. The sale of food will lead to the food waste problem and increasing food spoilage statistics worldwide. Many people nowadays are struggling with the catastrophic hunger, which is one step away from famine problem. The scale are increasing about 10 times more than 5 years ago. This issue can cause negative effects on the health of society, economic and social issues to many people around the world. So, what are the causes of this problem? During this work, I have studied that the main reason of stale food is because the entrance of oxygen and growth of bacteria inside the food. The entrance of oxygen can lead to the chemical changes and chemical reaction to occur. The bacterial enzyme that came from the presence of bacteria will affect the slow deterioration of food itself. The reason might be happen because of the weight barrier properties of the food packaging and also thermal stability of packaging. Many food packaging used nowadays have low thermal stability and weight barrier properties. Thus, there are some modification of montmorillonite clay can be done to enhance the performance of the food packaging to increase the shelf life of food and decreasing rate of oxygen entrance inside the food. The objective of this work is to modify the montmorillonite from hydrophilic to hydrophobic by the addition of trimethylsulfonium iodide surfactant via ion exchange reaction. Next is to prepare the polymer or the montmorillonite clay via intercalation method. The other objective is to use montmorillonite clay as an additive to food packaging to improve the properties in terms of barrier properties, mechanical strength and also thermal stability. The side objective is to investigate the uses of cationic surfactant inside the polymer matrix and mineral clay to increase the performance of dispersion for montmorillonite structure. Next, the significance of study for my work is to help decrease the famine issue and spoilage of food around the world. Proper food packaging plays a crucial role in preventing spoilage and preserving food. Next, it is to increase the shelf life of food to improve economy effectively across the globe. Lastly, is to learn about the thermal stability and other important properties of polymer clay nanocomposite. Trimethylsulfonium iodide exhibit high thermal stability, which can stand in elevated temperature without decomposing and undergoing chemical changes. The intercalation method is preferential method that has been used in our industry. Mild intercalation is the process where the molten thermoplastic such as polyethylene mixed with the organic clay. The mixture of solution will blend above the glass sensation temperature in order to produce nanocomposite products. It is eco-friendly method approach as the solvent is not required. The main reaction involves the modified surface of montmorillonite of ion exchange reaction. This reaction requires the replacement if the cation on the surface of montmorillonite. The surfactant will absorb into the negatively charged of montmorillonite layer and improve the hydrophobic properties of organic clay. It causes the clay to move apart and resulting in the expansion of interlayer spacing. The method of this work as follows. Firstly, the modification of montmorillonite by using cationic surfactant. Second is the mechanical testing to modify the mineral clay by using injection molding. Next is the FTIR analysis to identify the specific group present in the structure. Lastly is SRD analysis to identify the dispersion rate of modified clay. The spacing of interlayer montmorillonite can be measured by wide-angle X-ray diffraction. Instrument used is Heki Mini Jet 2 for injection molding, tensor test using universal testing instrument 3366 and FTIR analysis using protein analysis. This is the expected result at the end of the work. The interlayer spacing between adjacent sheets of monomerilonite can be measured. The changes in the structure of monomerilonite can be detected by SRD analysis with certain condition follows. There are increasing of mechanical strength of polymer nanocomposite after the modification of monomerilonite surface. The product will have good thermal stability and state of food can be avoided in shorter time. There are about several page shows in the FTIR spectrum showing the presence of compound in the modified clay. TGA used to determine weight changes under a certain condition. We can measure the degradation temperature of the modified clay and determine the thermal stability of the compound. The maximum temperature of the polymer nanocomposite can be measured at the end of the reaction. This is the list of references that I used throughout this work. That's all from me. Thank you for watching.